So in this video we're going to have a look at different molar concentrations to see how changing the concentration affects the performance of the batteries. So in each of these we've got the glucomannan and we have a different molar concentration of a table salt or sodium chloride. So we have 1 mole, 2 mole, 3 mole, 4 mole and 5 mole. And we have a similar size electrodes of a copper foil and aluminium foil. So what we're going to do is basically test these on a standard charge and discharge over a number of cycles and see how they perform and whether there's any major difference. I guess at this stage we could probably say having a higher concentration will probably improve the performance, but we'll find out whether it really makes a huge difference or whether it potentially plateaus out at some point and you don't really get any more gain. And also then we'll be looking at other factors like corrosion on the electrodes to see whether the stronger concentration increases that. So yeah, let's get the test set up and see what happens. So all the tests have been run now. We did 5 charges and discharges on each of the cells. So before we go and look at the results, I thought we'd just have a quick look at the state of the cells after the tests. I mean, you can see in here some of the main problems are evaporation within the electrolyte, causing the gel to solidify, and you can pretty much see that as a result of that the performance starts to drop off over the duration of the tests. You can see as well that we've got kind of blue colour within the electrolyte that's probably being formed between the copper and the chloride, forming copper chloride. And you can see on the aluminium side there's certainly some oxidization happening, which is to be expected. But yeah, let's go and have a look at the results now on the laptop. So here are the results of the discharge times. So we can see here we've got the different concentrations that we did. So each of the shot glasses, and we did 5 charges and discharges. What I did here was pretty much pick the best times. There were some issues with some of the charges and discharges where some of the numbers were kind of dropping off. Not entirely sure what happened there, but what I thought I'd do is probably pick the best times over the 5 tests, and you can see over here, plot them on a graph. So what's interesting is that you can clearly quite see as the concentration goes up, the performance increases. But I mean, you can see here it's not really linear. So pretty much if you're going to take 1 mole versus 5 mole, you can see here that there's quite a significant jump, particularly between going 4 to 5, which is interesting. So I think probably what we're going to do next is kind of explore 5 mole and beyond really, and try and see if it improves further or whether we get the plateau. So yeah, probably going to run another set of tests looking at these higher concentrations to see what happens. So just to round things off, here's a quick sample from one of the discharge tests I did. So this is the best time on the 5 mole concentration test cell. So as you can see here, it ran in total of 1 hour 18 minutes 28 seconds with a cut-off voltage of 0.3. You'll see here that it initially holds over a volt for around just under 15 minutes before it suddenly kind of drops off, and then it kind of hovers around half a volt for the rest of the test. I think going forward I'm probably going to have a cut-off voltage at 0.5 as I think I'm more interested in trying to see how long we can sustain this higher voltage going forward, and also hopefully it will mean that the tests finish a lot quicker, so I'm not having to sit around waiting for these things to run down to the lower voltage. But yeah, so yeah, that's it for now. So hopefully I'll be back soon with the results on the higher concentrations. So thanks for watching.